Hi everyone, Mike Hainer from the Canadian Ski Guide Association. In this short video, we're going to talk about how to start building a route plan. So if you look down at the map here, let's say we want to travel from this lake here, which is a little bit further east, and travel west towards this lake. We would first start with establishing our first grid reference, so our start point. So if we were to start at the western edge of this lake here, we would start reading our easting. So as we move across, this is 50, 51, 52. This would be approximately 524, let's call it, as our point. So we can start by making a point on the map. And we would fill that out on a nice handy sheet. You can use your guide's book or a sheet of paper, but grid reference to start. So 524 is the easting for our start grid reference, and our northing, if we look at the map here, is 71, let's call that 5. 715. So this is our first leg. And now we have to travel west towards the further westerly lake. So let's say we want to travel to this point here. Now we repeat the same process. So our easting, if we see up the top here, this is 50 is the dark line as we move across. So 50, 51, not quite 52. So this would be 51, let's call it 4. So our grid end is 514 easting. And northing, we go up here, 71. Let's call that 712. So our grid end is 712. Now we want to know our elevation start and our elevation end and the change, whether it's positive or negative. So if we look down at our map, it's going to be hard for me to zoom in more, but you'll have to trust me on this. The contour line just above the lake here is 6,000 feet. So the lake is essentially about 100 feet below that. So we'll call that 5,900 feet. And as we travel across, we're going to gain 500 feet, 600 feet, 700 feet to the saddle. And then we're going to descend 1, 2, 3, 4, 5, 6, 700 feet. So essentially, our elevation start and elevation end are pretty similar. Elevation start is about 5,900 feet. And our elevation end is 6,000 feet. So our total change is plus 100. But what we might want to do in the terrain descriptor is mark something like saddle plus 700. Because we know we had to gain 700 feet to make the saddle in order to descend the other side. Gaining elevation is obviously always a lot slower than losing elevation, so we want to make note of that. And now we need our forward bearing and our back bearing. And the back bearing is important in case we end up in a situation where we need to back out of our route plan so we can more easily reverse ourselves. Otherwise, you can just write the forward bearing, and if you need to retrace your steps, just subtract 180. But keep in mind that that can be difficult when you're in the Alpine and it's blowing 60 miles an hour and you've got whiteout conditions. And now you're trying to do math at 8,000 or 9,000 feet. So sometimes it's easier to just do the forward bearing and the back bearing when you're building your route plan. So in order to get our forward bearing, we have to use our compass properly. So we decided that we were going to travel from the more easterly lake to the more westerly lake. So that means our compass needs to be in this direction. If we get going in this direction, our bearing would be wrong. Our forward bearing would be the back bearing and vice versa. So in this case, we line up the 2 points that we decided to line up on, and then we turn our base plate so that the grid lines inside the base plate line up with the grid lines on the map. And once they're parallel, we get our forward bearing. So in this case, it reads approximately 260 degrees. Now we have to ask ourselves when we're building our route plan, does that make sense? Does 260 degrees as a forward bearing make sense? So remember, we're traveling from the more easterly lake to the more westerly lake. And if we look at our compass, west is 270 degrees. So we're actually traveling ever so slightly southwest. So 260 degrees does make sense as our forward bearing. And you can see our back bearing here is slightly off of east because we're slightly off of west, and our back bearing is 80 degrees. So we'd write that in. Our route plan, forward bearing 260, back bearing 80, and now we have to calculate our length. So you might remember from earlier videos, we discussed using our ruler along the bottom, and that each of these squares is 20 millimeters or 2 centimeters. And that represents 1 kilometer. So now we're going to measure the distance between our 2 points. And we start at 0 and we go to 20. It's almost 1 kilometer exactly. So our length, and you can choose whether you want to use kilometers or meters. 1,000 meters is 1 kilometer. And then we have to determine what amount of time we think that will take us. As a general guideline, if you're gaining 1,000 feet, it'll usually take about an hour, depending on the nature of the terrain and the difficulty of travel. The more complex the terrain, the deeper the snow, the more arduous the travel, the longer it's going to take. The more simple the terrain, the fewer hazards, slope angle, etc., the time will be shortened. But in mountain environments, 1,000 feet of gain is approximately an hour time of travel. And in flat environments, the average person can usually travel 3 to 4 kilometers per hour in flat environments. So in this case, we said we made a note in our terrain that we were probably gaining about 700 feet, and then we were descending to the lake. And the descent won't take very much time at all. It's a few hundred vertical once we peel our skins off and start to descend. So if we're considering good weather, nice alpine travel, probably 45 minutes to do this leg in good time. And that's the first leg of our journey. And then we would go on to build further legs as we move through. Hopefully you found this helpful, and we wish you luck building your route plan.